Hi guys, this is a video that goes over an AP question related to what we've been doing in class, which is matched pairs T procedures. So this question is talking about there was an investigation done about the ages of grandparents of high school students. So they took a random sample of 10, that's N, high school students. So first of all, keep in mind that it says from a sample of high school students, so the population is all high school students. And from that sample, they asked the ages, the current ages of the students' maternal grandparents. And then what they did was, it looks like they found the difference of the ages of the grandparents, grandmother age minus grandfather's age. So here would be student one, and the age of the grandmother was 75, the grandfather was 74. The difference 75 minus 74 is positive 1. So the grandmother was actually 1 year older than the grandfather. Now we have the next student, student B. The grandmother was 70, the grandpa was 75. 70 minus 75 is negative 5. This negative indicates that the grandfather was greater than the grandmother. So on the side, you may want to note that a positive difference means that the grandmother was greater than the grandfather's age. And negative difference means that the grandmother was less than the grandfather's age, which means that the grandfather was greater than the grandmother. So it says down below, construct a 95% confidence interval. So let's write that down, C, for the mean. Notice it says means, so you already know that it's probably a T interval. The mean difference in ages, okay? So the mean difference means that you're doing an interval to estimate the mean of the differences. This indicates that this is a one sample procedure because you're just doing one mean and one mu, and you're spotlighting the difference row, which is what we went over in the last video. So you only care about this row here, all right? So if you wanted to, you could put the data in L1, and I just want to remind you how to do that. You press second plus sign for enter, clear your list, and then stat edit and enter the data in L1. So do that now, please. The next thing that we're going to do is run one variable stat on the data. Even though they actually have it here, which I will show you, they do have the information that we need here, mean and standard deviation, X bar and S. So I just want to show you that we can find this as well by pressing stat, going over to calc and choosing one var stat, and it's L1. So I just want to remind you guys that I only put in the information of stat edit of the differences. So I did not put in the grandparents separately. I just looked at this difference row and I just only put in the differences 1, negative 5, negative 10, 8, etc. So that's why you only see L1. So again, I press stat calc 1 var stat. I changed it to L1. And when I hit calculate, I get a mean of negative 1.8, which I have here, the mean. That's the sample mean. And the sample standard deviation S is 5.81. So now the reason why I put it in L1 is because I'm going to have to plot the data when I do my assumptions. And the reason why is because n equals 10 is not greater than 30. So I can't use the central limit theorem. So I know I'm going to have to plot the data. So I might as well just put it in the calculator now. So I'm going to press second y equals, hit enter on plot 1, hit enter on the word on, go down to my modified box plot, make sure there's nothing in y equals, and then I'm going to press zoom 9, which is zoom stat, and here is my box plot of my differences. And the reason why that's important is because I want to assess normality, and if it is approximately normal with no extreme outliers or skewness, I'm going to address that in my confidence interval. Okay, so we are going to do the full panic procedure here. So we're going to set it up. P, population of interest, parameter of interest. We already said the population of interest above was all high school students, but the parameter of interest was, this is where I wanted to spotlight today. Mu sub diff is mu instead of X bar because that's a parameter, and that's the mean of the differences, because it says it right here, the mean differences, take it right out of the question, of ages of high school students, grandparents. And then I want you to specify the direction of the subtraction. So it's grandmother Mother minus grandfather. Grandmother minus grandfather. Okay, so that was important today, was to spotlight the parameter of interest that we're focusing on. Some people use mu sub d, or you could use mu sub diff. Okay, now you're going to do your assumptions. So I want you to do, is it an SRS? I want you to do 10n is less than the population of interest, and I want you to refer to your plot. Okay, and you guys can do that. Then I'm going to skip ahead to the name of the test. We said it's a one sample t interval for the mean difference. It's t because it's means. And now let's go on to the interval step. Same formula for the confidence interval as yesterday. It's x bar plus or minus critical value. I should go back to statistics, sorry. Statistic plus or minus critical value times standard error of the statistic. So this was x bar of the differences plus or minus t star, because it's a t interval, not a z interval, times s over radical n. Now let's substitute in our x bar and our s. Our x bar was here, negative 1.8. So that's going to go in here. And our s is also up there. We got to look up t star and radical n. So s was 5.81 and radical 10. Okay, so that's a 5.81, guys. Sorry. That was the standard deviation of the differences. So this was a 95% interval. The degrees of freedom was 9 because 10 minus 1 is 9. So I looked up table B. I looked up the degrees of freedom and the 95% level, and I got a critical value of 2.262. So I plugged that into my t star right here. And now I'm going to go to my calculator to get my interval from the calculator, and then I'm going to go right to my conclusion. So when we do this, we're going to go to t interval. We're going to press stat, we're going to go over to test, and we're going to choose t interval, which is number 8. If we have data in our list, which we do, we're going to choose data, which is nice. And then you're going to put in the list it's in, which is L1, second 1. And then you put in 95% level, and you would hit calculate. So I got my interval. But let's say I didn't have the data in my list. I could press stat, test, and I could choose number 8 again, t interval, and I could choose stats, and I could just type in the x bar by hand, negative 1.8, and the s value, which is the standard deviation of the sample, by hand, and I should get the same interval doing it this way, but this is not rounded, so it's a little more accurate. So I end up getting an answer of negative 5.9555, comma, 2.3548. Okay, so now I write my sentence, which is my conclusion in context. This sentence goes, I am 95% confident that the mean of the difference, and here I recommend you just go right back to the problem and just take their verbiage straight from the question. I'm 95% confident that the mean of the differences of ages of grandparents of high school students is between, and then put in that negative 5.955 years to 2.3548 years. Okay, so it's just like a little different because you're using mean of the difference instead of the true mean. Part B, one of the sociologist's research questions was about the mean difference in the age without regard to which grandparent was older. The interval constructed in Part A does not address such a question. Based on the sample of high school students, given the value of the point estimate for the mean difference in age that could be used to address the sociologist's concern. I did not realize that this question was not asking what I wanted it to. I wanted to actually address, skip this for now. I wanted to actually have him address if the interval does significantly make a decision about which grandparent is older. And if we had tied this now to a hypothesis test, the mu d equals 0, and mu d is not equal to 0, or whatever, if we wanted to do mu d is less than 0, because maybe we think that the grandma is always going to be less than the grandpa in age, what we see in our interval from above, which is negative 5.955 to 2.3548, is that 0 is contained in the interval. So because 0 is contained in the interval, we can't definitively say that all the time that the grandpa is greater than the grandma's age. So because 0 is in the interval, 0 is plausible or possible, so we fail to reject the null hypothesis. So that's what I wanted to say about this, is this interval does not give us clear evidence, I'll say statistically significant evidence, that the age of the grandma is less than the grandpa, or that the mean difference is less than 0, because it could be positive, it could be negative, it could be 0. 0 is contained in the interval, so you failed to reject the null. Remember, if you graph this, you would see that the 0 would lie in the interval in the middle, and if it's in the middle, the p-value is not low, so you cannot reject the null.